resume recording.
Okay, Billy asked me to introduce 2025, but I just learned that our president, Dr. Gladys Completo, is actually here with us. So Gladys, I will let you do the honors. Paki-highlight kay
Impromptu
Gladys.
ito, Madam President, ha? Okay.
Kararating lang niya. Miss Gladys.
Yes, hold on, please. Could
Okay, there she is.
you start Marge, and then I'll just continue what you're gonna say.
Oh, well, you know, I had nothing prepared because the Billy put me on the spot, but I just wanted
Oh,
to
yeah,
welcome
everybody's on
everyone.
the spot here.
Yeah, on the spot. We're all on the spotlight. But anyway, I just wanted to welcome everyone to a new year. And PAASE, as our president has outlined in her last newsletter, has a lot of exciting events planned for the coming year. And so we will have all of those posted on our website, and we hope that everyone will have a chance to attend all of them. And tonight is actually one of the most exciting one. We start with a great talk that was organized by Billy Cabellon, who as always has done a great job, and he will introduce our speaker today. I don't want. I would like Gladys to talk about some of the initiatives that she has
Okay.
planned because she's worked so hard to put them together. Gladys, you can continue now from where I am.
Okay, so good morning, everyone. Welcome to PAASE's first event for this year, 2025. And first of all, I would like to thank Billy Cabellon for really organizing this. And he has put a lot of efforts in preparing this first webinar series. And we're very excited about this. So let me just give a short opening remarks about Annie Hartley's webinar, and then we'll take it from there. Okay, hold on, please. Okay, so on behalf of the Philippine American Academy of Science and Engineering, or PAASE, I welcome all of you to this important webinar. And we are gathered here today to explore a critical area of modern healthcare, the transformative potential of large language models in democratizing access to medical knowledge. So as you know, the abstract eloquently highlights the significant challenges encountered in the practical applications of LLMs with the healthcare sector. These challenges underscore the urgent need for innovative and effective solutions. So today's discussion will focus on Meditron. It is an open source medical chatbot meticulously developed to address these critical challenges. I hope I introduced it correctly. And the evaluation of Meditron will not only assess its performance, but also critically examine its real-world clinical utility, safety, and trustworthiness aspects often overlooked in traditional assessments. So I warmly invite you all to join us in this important endeavor. And we are very fortunate to have with us a distinguished expert in the field of LLM development and Meditron research. And your insights will be invaluable as we advance the field of generative medical AI tools. And we anticipate your active participation for the success of this webinar. So thank you for your unwavering dedication to improving healthcare accessibility and excellence. Thank you to our guest speaker, and I look forward to a fruitful and insightful discussion. Thank you.
Thank you, Madam President. Before I begin, I'd like to acknowledge the presence of Dr. Gisela Concepcion, Dr. Engineer Tito Aliga, Professor Prospero Naval, Dr. Iris Tan. There are some VIPs, and of course, our chair of the board, Dr. Al Safarika. There are big names here that I cannot all mention, but thank you very, very much, and everybody for joining us. I am Silverio Cabellion Jr. My arm was twisted to join PAASE by Dr. Yasmin Ronquillo. And so here I am. So let me introduce our speaker tonight. Dr. Marion Hartley is an assistant professor in bioinformatics and data science at Yale. Her research is focused on developing and validating novel data-driven tools designed to improve healthcare in low resource settings, with a special interest in Africa, soon to be Asia. She completed her undergraduate degrees at the universities of Pretoria and Cape Town before moving to Switzerland, where she completed a PhD and an MD at the University of liaison with a master's in public health at the famous London School of Hygiene and Tropical Medicine. In 2019, she started the research group Intelligent Global Health in the School of Computer Science of the Swiss Institute of Technology. Looking at the website of this Swiss Institute of Technology, it's massive. I cannot tell you how big it is. And she continues to work in this campus, leading the Laboratory for Intelligent Global Health Technologies. Through these groups, she maintains a strong presence and partnership with EPFL and Yale through student exchange, research collaboration, and a visiting professorship. The groups collaborate with international NGOs and clinical partners, and they validate needs-based digital global health technology using novel approaches in data science and informatics. So how did we stumble through the radar of Dr. Hartley? We were trying to mentor some medical students and residents at the Philippine General Hospital. We are going to train a chatbot with Philippine data. And lo and behold, my partner here, Dr. Paul Pontello, discovered the work of Dr. Hartley. So, not much ado, I called up Dr. Hartley. But why should I tell you what we said? She's going to say it herself tonight. So, Dr. Hartley, ma'am, your floor. Thank you for joining us tonight.
Thank you so much for the wonderful introduction. And before I share my screen, I just want to say that I'm really honored to inaugurate the 2025 PAASE, and really excited to be here. I'm really honored with the VIPs in the room, but actually it's exactly the audience that we need, because the talk that I'll be giving today is not just a talk. It's not just about promoting my work. It's actually an invitation. And I would really like the best people in the world that know their context to participate in what we are trying to do, which is trying to make access to these really expensive, very difficult to make tools, to make it accessible to places that maybe don't have their own, or to actually make them adapted to the contexts that are underrepresented in medical literature. And this is exactly what we need. We need the best experts in that context to participate to ensure that this works. So I'm in the right place, it seems, because this is where they seem to gather. So without further ado, I will also share my screen and start the talk. And here we go. You should be able to see it. Is that right? I think so. So the talk today had a lot of acronyms in it. You'll see the words LLMs and Move and Meditron and all sorts of things. I'll try to explain them as we go along. But all you need to know is that this is not just a presentation. As I said, it's an invitation and something to join the Move, which is a massive, right? That's the M, and massive is very important. And you'll see that massivity or bigness and many people participating is a critical component of what we're trying to do. Generative AI tools and chatbots can have so many different ways of answering questions that we have to test them in as many different ways. So massive is important. It's not just very big, it's massive. We also want to make sure that it's open and online, which are the two O's over here. And open because we are making tools that are specifically open source that can be accessed by many people. And these tools are very expensive to make, millions of dollars, and they are public goods because they contain knowledge, and that knowledge should be open. We also want to make sure that it's accessible. So it's an online platform that I'll show you. We'll do a live demo. And what we are doing here is we are validating and evaluating these large language models and chatbots. When I say large language model, it's a chatbot like OpenAI's ChatGPT. And we're trying to evaluate them for clinical practice. These tools need to be validated when they are in clinical practice. And what we're doing is through the evaluation, we can actually evaluate and then use those evaluations to tell the model in which direction it should go. So there's a continuous real world alignment. We're shifting the model, nudging it in the right direction. And this invitation would then be to make a clinical chatbot tailored and evaluated for the Philippine setting. So I've already introduced myself, and there were a lot of acronyms over there and a lot of logos, but those are all the people who are participating. And actually, just to update you on this part, over here you'll see that my lab is called Laboratory for Intelligent Global Health and Humanitarian Response Technologies. There's a little update that I'm now not just a visiting professor for from the 1st of January. I'm now a full professor or a professor at EPFL, which is the Swiss Institute of Technology. It's our MIT in Europe. And then we're just doing, no medical school, just tech. And then in Yale, and then also in Carnegie Mellon University, Africa. So this is very important, actually. It's not just to say, oh, our lab is big. It's because these tools cost so much to make and they're so difficult that we need collaboration between different universities just to get them right. So that's why we're trying to share it. One of our biggest people that we're working with, or biggest groups of people, is the International Committee for the Red Cross, who originally initiated this with us to say, we need these tools in the field. So, they don't take any nonsense, ICRC, and MSF and other humanitarian organizations. They want to make sure that their tools work and that they're evaluated to work, because they don't have any safety nets in these very vulnerable areas that they're working in conflict zones. So it's very important that we have that pressure to make things that are actually actionable. So let's get an example. Let's dive right in. And I work mostly in Africa, so that's why I'm very excited to be here today, because it's a new place for us. Here's an example, very tangible, about what is the potential for these tools in practice. Here we have Carol, who is a community health worker, and I think you have similar structures in the Philippines, where there's community health workers that go to directly to the patient, right, at their bedside and in their houses, and can follow them up with various forms of care. And right now, these clinicians and health workers, if they have a question that can, direct the healthcare and life-saving healthcare, they can actually right now go to ChatGPT on their phone, as long as they have a phone and a connection. And this technology is not something in the future. They can right now ask, oh, I'm a nurse in Sudan and I have a 1-year-old child who has difficulty breathing. What can I do? They can ask this question right now and get very reasonable and actually extremely clear responses from these chatbots. This is not something in the future, and I'm sure all of you have played with these chatbots. And the point is that she can actually even go further, and she can say, well, if her maybe friend sent her an image like this that says, well, if this child is, you're in the middle of the bush and you really can't get this child to breathe, well, you can actually make a bubble CPAP, which is this, if any of you have done this, I've done it many times in Africa, and she can take a photo that she got on WhatsApp from her friend and say, my friend told me to make this. What is it? Can I do it myself? Share an image. These chatbots can recognize images, which is multimodal capability, right? So multiple modalities of text, images, sound, etc. And it can give extremely accurate instructions that I know how to make these things. I've made it with many different things, with beer bottles and all sorts of stuff. And these instructions, I can tell you, are better instructions than I would have been able to give Carol, because you know what? I wouldn't have had the time to do all of that when and to be responsive immediately. And that's why it's better, because there's nothing more powerful than the right information, but at the right time and in the right place. And let's not be hypothetical here. This is actually what happened to Carol when I was busy visiting her in Kenya. And let's have a real situation. So Carol visited a patient in a suburb of Kenya, and this patient had a stroke, and she was following up for a stroke. And so what she did was she was asking questions on a mobile application that is given to her by the government. And then she took his blood pressure, and the blood pressure was high. So he had like 180 over 100. And she was like, wow, this is really dangerous for someone who's recovering from a stroke. Are you taking your medications? And he says, yes, I'm taking my medications. And he puts the medications on the table, and he says, well, here they are. And it's loratadine, which is loratadine in the country there. And if you know anything about medicine here, I think I'm in a room full of doctors, you'll know that this is an antihistamine. So I noticed it, of course, because I was in the room. And I asked Carol, like, how do you know? Because she had already pressed yes on her phone. How do you know that this is an antihypertensive? She said, well, I don't know. I have no one to ask. And so I asked her to then go and take a photo by herself and use ChatGPT, upload it, and ask a question in her own voice, in her own language, which is Swahili. And ChatGPT was able to answer fluently in Swahili, not only to her to tell her that this is not the appropriate medication, but also to explain to the patient that they need to go to the hospital. Right then, Carol was able to change the destination of that patient from taking treatment appropriately to not taking any treatment. And it changed the direction. The next day, the patient was able to go to the hospital and get the appropriate care. And so this happens right now. We're not talking about something in the future. This is actionable. And I want to make sure that there's an understanding that this can work right now because it's actually publicly available. The problem is that, of course, ChatGPT is not you have to pay for it. You can't send private information to it. We don't own it. And there's lots of problems because it is proprietary that you don't know. Maybe tomorrow ChatGPT updates their model and has a deal with some pharmaceutical company and gives unvalidated information that is beneficial to their bottom line. And this kind of lack of control is not something that is acceptable in medicine. And also we can't make sure that it is appropriate for our setting. So this is the effort that we're trying to make to make sure that we can have an evaluation platform that can understand how these models work. And that's what the move is about. It's about making sure that these models are locally owned, that we can have community alignment, that a community of experts and doctors can ensure that they can own the models themselves without having to rely on a paywalled option that is continually increasing in cost. We also want this expert validation from the best experts so that they can co-create these tools. Many of you in the room may find, and I find that with about 80% of the doctors that we are in any country, from Switzerland to Kenya, 80% of them think, AI is still quite mysterious. It's something that they haven't ever played with. They maybe play with ChatGPT occasionally, but they don't feel like they are invited into the development of these tools because it's too complicated. It's outside of their field or something. But actually, this is an opportunity to co-create these tools, to be part of its development, and to create them with your expertise that you currently have. These tools are conversational. You can have a conversation with them. So why not direct them and steer them with your conversational skills in your expert group to co-create them? We can also make them more accountable, because when we have public and transparent oversight on these models, rather than a closed source model like ChatGPT, we can actually make them accountable to public scrutiny and name and shame them when they go wrong so that we can improve them. And we don't obviously just want to name and shame. It's only evaluation, and that's kind of the wrong idea to have behind it. But the concept of calling out errors is very important. It's the scientific process. We also want continuous learning, and that's because medicine is dynamic. It is updatable, and it changes all the time when we are busy practicing. So we can't just have these tools that are static with knowledge that is static when we have this dynamic environment around us. So it's important that we update our tools accordingly if they are reliant on information. We also want to make sure that they are then finally adapted. And this is the most important part. We want them to be adapted to the nuances of our setting. So that is the overall structure of the move. But you can look at it in another way and call it a model nudging platform. It's a way that you can take a model. You can imagine kind of these models as these blebs over here. And this is the large language model or a chatbot. And you can imagine that you can nudge it by evaluating it and going, that's not right, and pushing it in the right direction when you ask it challenging questions and evaluate the answers that it gives until you find a direction that the model is now starting to learn from how you are nudging it. And that's what we are proposing here. So just to give you a bit of a insight into how this fits into our research, I told you that we have a laboratory that's in these 3 countries, and that we obviously we're traveling quite a lot. But what we do is we do implementable digital global health, which is and so how does the move fit in here? First of all, we collect data. So we start up over here and we make sure that when we collect the data, we also make platforms to ensure that the data is ethically managed and locally owned. Local ownership is so important. And once we've done that, then we make some models. And these models are, of course, the chatbots, right? So if I try to say what that would be, that was when you can hear the word Meditron, which is in the title of the talk, right? So Meditron is one of our models. These are our little logos that we make for them. We also have other models that can talk about other things. So we've got one that's talking about international humanitarian law, clinical practice. So we change them each time, right? They cost a huge amount of money to make. These are foundation models that have a foundation of knowledge in them. And then we make these platforms, which is the move, that allows us to close this gap between the model and an actual patient interaction and utility. And we feel that the move fits in perfectly here to close this gap in implementation so that we can use the model. We don't have to wait for it to be perfect. We can use the model and perfect it during use under controlled environments. So why are we doing this? Well, the thing is that you might have heard all of the narratives, depending on how much you are focusing on AI, that, rubbish in, rubbish out. It's a big like adage in AI and machine learning. And we know that in low resource settings, especially in Africa, these are some of our data looks like this, right? And in PubMed, even if we decide to use PubMed, less than 3% of the information and the publications on PubMed are representing the African setting. How much is it representing the Philippine setting? Who knows, right? So these kinds of things show that there's just an underrepresentation of our sorts of settings. And then what happens is what a model is, what any AI tool is just a representation of data. A model is data. So if you've got imperfect data, you're going to have an imperfect model, and then you're going to have an imperfect application, right? So we need better data. But is that really true? Because if we wait for better data, when are we going to get it? It's going to take forever. We can't just like launch a countrywide initiative to collect data. Everyone's been trying to do that. It doesn't work. And you'll take so long that everyone will eclipse you and surpass you by using all of the tools already in their setting. So what we have to do is we rather accept, okay, fine, well, PubMed isn't perfect, but we rather take that imperfect model and use it, but nudge it towards a perfect state or a more adapted state. And that's what the move is about. It's about taking an imperfect model, which all of them will be because there's not perfect data, and to nudge it so that it's better for your setting, and to empower people to have access to these tools that are perfect in other settings, in high resource settings, but to make them perfect in yours. So if we kind of like then see what we're trying to do, we take Meditron, we nudge it, and then we have it for all of our different countries. These are the countries we're running a randomized control trial in Africa, and then we nudge it to those settings so that we can have sub-models that represent those settings, and that is what we're trying to do also then in the Philippine context. So we do this for anyone who is more technical in the field. We do it with direct preference optimization. You don't need to know these words, but reinforcement learning by human feedback. It's pretty standard. You can imagine what that means. We reinforce the model through learning with human feedback. So these are quite standard techniques we're using. And we also use retrieval augmented generation and fine-tuning, but those are details. But you can imagine that retrieval augmented generation, you'll see the words mean exactly what they say. We retrieve information from a set of documents, for example, that you can provide us, like some guidelines you follow. And then we can make sure that the model follows those more than just the general text that it is, created on. It's not just following, Moby Dick, but following some guidelines that you've maybe given. And, these models do follow Moby Dick and other things. They need to know how to speak. They need to, just like us, we learn how to read with books. So it's exposed to a lot of data, but which data should it use to answer your specific question? And that's what we try to use for a retrieval augmented generation. So Meditron, as you've seen a few times here, is this model. And it's got these numbers in them. So this is our third iteration of it, for instance, and we've got different sizes. You can see this one's small, this one's bigger, and I'll tell you about what those sizes mean. These are parameters that we are training. So big and small. Obviously, the bigger the brain of a model, the better it is. So it can speak better, just like humans. So what it is, it's a modular suite of LLMs. So these are large language models for clinical practice. And you'll see why I say modular. And it's a real suite, but it's almost even like a pipeline. We can make any base model Meditron, and we can Meditronize things. You can make it more medical through our pipeline that we've been creating. It's co-designed by clinicians. It's multimodal, so it can also see images. And it's multilingual, but it still doesn't speak all the languages that need to be spoken. So we really want to test it on that. And it's specifically adapted to low resource settings and humanitarian contexts. So how are these made? Just a few interesting facts. It is a generalist open model. So first of all, it's based on a generalist open model, I meant to say, and we use Meta's Llama. That's why we've got this Llama model here. It's called Llama, and it's an extremely expensive undertaking, just getting a model to speak. So what Meta did, they made a hugely interesting decision to release their model open source, which completely changed the way that we do science in general. I mean, like in AI, the field changed after these models were released because they were so expensive and unobtainable before. And to put it into context, how much information, because a model is just data, so how much data goes into these models? 11 trillion words was for this latest model that has been released. 11 trillion words is equivalent to about 180 million books. And in an average like academic library, there's about 1 million books. And if you wanted to try to sit down and read every single one of these books, one after the other, at an average reading rate of 200 words per minute, without any coffee breaks, it would take you over 10,000 years, right? So this is the amount of information that is getting, that's why the large in large language models is large. It's the stuff that's going in there is large. And it goes into what? It goes into these models that have different numbers here, which are parameters. And this is roughly equivalent to brain size, right? So the parameters here that we're dealing with, you can see here this biggest one that we have the 70 billion parameter. It's about this size, right? Just relatively to ChatGPT. ChatGPT is actually much bigger than this now, but this was the estimated size of about 1 trillion. So you can see it's already at a disadvantage, these small models. But if we make our models very specific to a topic like medicine, right, even if it's a big topic, we can maybe be as good as these models and compensate for size with specificity. And that's what we're trying to do. Now, what does parameters really mean? Well, it's roughly equivalent to the synapses in a brain, right? You could think of it like that. And if we try to say how many synapses are in a brain of an average honeybee, we would be at the size of 1 billion parameters. So that's the average size of that brain. So just some interesting facts. Do with this what you want, right? But that means that our honeybee brains, if we have about a swarm of 70 honeybees, that will be the amount of brain size that we have in these models. So it's very impressive what they are retaining. And if you've ever played with ChatGPT, you'll know how intelligent it is, and it's about the average size of your average squirrel. So now do with this what you want again, but the average size of a human brain in terms of synapses is about 110 trillion. So 110 trillion is times what ChatGPT is, or 110 times. And interesting fact, the killer whale has 300 trillion synapses. So that's just to kind of give you a scale of what large means in large language models. We don't just use Llama anymore. We also use the open source models that have since been released by Google, and we're making our own as well, called the Alps-based model in Switzerland. And what we do is we take these models and expose them to very high quality and specific guidelines. So we enrich the content that it understands in low resource settings. And that's how we make Meditron. So we expose it to this information. It's extremely costly. It costs them nearly $100 million to make the base model that just knows how to speak, that has been exposed to those libraries. And it would cost us usually about $5 million just to train the model. But luckily, through those partnerships between different universities, and especially by the Swiss government, who has got a huge amount of computational power, we were able to do it almost for free, with all of our students being like really a student-driven initiative. And we went even further. So after we made Meditron, we also wanted to be able to see. And so we exposed it to a whole lot of images, radiology, pathology, others, so that we can actually make a multimodal model, like just like it would with text. So it takes the bits of pieces of images, if you're interested in knowing how it works, just like it would with words, and it lets it finish the sentence. So that's how these things work. They work in sequence. It takes numbers or inputs. Inputs as like, let's say you've got a word or a piece of image. It takes that, changes it into a number, and just has to find the right number. And when you find that right number, you can then do mathematical equations with it, right? So it can do it any way it likes. So it's modular. So we have a module for X-ray, a module for ultrasound, a module for ECG. So we have a multimodal modular model that can do this. So you can compose it. You can pick and choose your modules that you need, and then also put that to use. So how do we evaluate these things? Well, we were very happy in the beginning, of course, because we then decided to test the model with the standard benchmarks that are out there, which are really difficult things to do. I think all of you have taken the USMLE exams, and all of you had to prepare for multiple months to do it. And they are hard, right? There's no question about it. They are hard. There's also like this, the Indian licensing exams for medicine. And these exams are really hard. And also like to finish PubMed articles, or to like kind of have knowledge from PubMed. There's multiple choice questions. And when we tested them on these questions, Meditron actually was equivalent or even outperformed ChatGPT, and is getting even better as time goes by. And we see that our small model is able to beat ChatGPT in these settings. So very proud of how our model is performing, and it's the best according to these benchmarks, the best model for medicine, and that's open source as well. So we're very proud of this. But we have to remember that evaluation, right, is, and real world medicine, it's not multiple choice. We don't have patients coming up to us saying, I've got chest pain, and it could be A, B, C, or D. That's not reality. So when we test these models that are supposed to work in reality, we can't rely on those static benchmarks. And it follows Goodhart's law, which is very, very wise. It says that when a measure becomes a target, it ceases to be a good measure. And that's true. When you know what you need to get right, you tend to focus just on that. And maybe our model just knows how to do A, B, C, or D, and it doesn't know how to perform logic or be useful and empathetic beyond that. The truth is that those questions that are multiple choice, they are oversimplified. You wouldn't trust a doctor who has just graduated medical school, even if they have a perfect GPA, to be alone with patients. And neither should we trust these models on this evaluation criteria. They are static. They don't change over time. And a lot of them become outdated. And so we need to go beyond just accuracy, because medicine is about accuracy, but most of it, as we know, is about like contextual alignment and it's about empathy. It's about so much more. It's an art, and we know it, right? So we need to make sure that we have this continuous alignment. We need to make sure that we don't have this like a biased evaluation, and we need to surprise the model when we are evaluating it. So why do we need to do this? Well, we need to make sure that the most important thing, that we have a context-specific evaluation. Now, I'm very interested to see what the Philippine kind of setting is on this, but our patients in Africa have a very specific journey, right? They have a different patient journey in every single country within Africa, but in Africa in general, they have a different journey. 80% of our population seeks care at traditional medicine before coming to a hospital. And that means that they can have delays, but it also means they can be exposed to different drugs and medicines. So here are some of the drugs and medicines that are sold on the side of the road. These are photos that I took while I was volunteering in one of the hospitals in South Africa and here in Cameroon. And you can see here that these are all like seeds and herbs, and they're curing all sorts of things. Like here are some things I've never seen before, like worms of the woman. Who knows what that is? But you can see the information that people are getting in these places, and how they understand this kind of information infiltrates into their own local knowledge of medicine. So how do you kind of converse with people and patients in the setting? You have to know the context, and it's so important to know that, to be able to engage your patients appropriately. And now we can all, think, oh, this is so unreasonable that they're taking these crazy medications and all this stuff. But what's the alternative? To wait in this queue all day? Low resource settings are different. The patient journey is so convoluted that people have to make different decisions, and those decisions are often wise for the context and the resources that they have themselves. And we have to respect that and understand the right questions to ask for our patients that represent their setting. It also means that we have our own fake news. So, for instance, this is in South Africa, and we have all of these things that are sold just underneath the head and shoulders, all these things that are curing COVID and sexually transmitted diseases. We have this flyer that was passed out to me at a traffic light, and you can see this, Dr. Rashid here, right? He's doing all sorts of stuff, right? He's a fortune teller. He's also a doctor, evidently, and he's doing all sorts of things. He's not very good at formatting. Poor Dr. Rashid. He's got 2 number 16s. He's got 12A, 13B. Who knows what's going on here? But the thing is, like, you can laugh at this as much as you want. Like I think this was the number 7 was my favorite. Blindness / body pains / vomiting all the time, right? You can laugh at this as much as you like, but then it becomes very sinister when you see the second or the first number 16 here, that he's claiming to treat HIV/AIDS as well. And you can see that this fake news also needs to be made sure that if we're going to be releasing these chatbots to the public, that we can probe our models to see if it contains this kind of fake news in our setting. How does it respond to that? And this is very contextually specific. So we need to ask challenging questions to these and go beyond just accuracy, and make sure that we are evaluating it in the same way that we would evaluate a student that is in real world practice. So you can see here, if you go beyond accuracy, you can break that down into question comprehension, logical reasoning. Did it have relevant context? Was it aligned with the guidelines that we are using? Was it complete? Did we trust it? How much confidence did the model show? What was the possibility of harm, the extent of harm, the bias, the tone, vocabulary, clarity, harmfulness, So all of these things are important, and we evaluated Meditron, and everything that is dark here, we've actually got an updated one. This is our previous version, but it's still great. We're very proud of it. It really performed really well when doctors themselves evaluated difficult questions that were asked to the model across these very many metrics. And this is what we are doing in the move, right? So it's over 85% positive, and our doctors actually prefer Meditron over our new version, over ChatGPT 65% of the time, which is really a good indication of how it's working. We've got over 10,000 evaluations with 300 medical specialist doctors across the world already working on this in different countries to align. So what do you have to do? Well, you have to gather your colleagues, ask our chatbots difficult questions related to your context, and then rate the answers, which one's better, which one's worse. And then the reward is that you get your own chatbot back and you're able to publish the findings because everything is your own, right? So that is the move. And I quickly want to end then with a demo. And if you have any questions as well, we are also going to be doing a clinical trial. And I can just show you some like overview diagrams like this about our clinical trial, right? But I'll just give you that's just a little taster. But I'll just quickly rather want to end. So I'm going to just quickly reshare my screen for the last minutes that we have. And share my screen so that you can see the actual demo. I just have to share the right one. Where is it? Here we go. So true to the name, right? We have Move as one of the O's in Move is online. And here it is. It's an online platform and it's easy to access. And you can see that we've got Meditron here, Legitron, we've got all sorts of things. And you can see up here that it's my name, Annie Hartley. So I've logged in because it's only open to experts. There's not some like, random teenager in Ohio or wherever who is on here. It's only medical experts that have been validated who are making an effort. And what we're trying to do then is it's a collaborative platform where experts can share their knowledge to align our AI tools with real world medical standards. And then the tool is yours, right? There's nothing we're keeping from this. It's about providing access. We've already told you all about the transparent community-driven evaluation, about continuous real-world testing, and that we can have any kind of model to be tested here. So we are also working with a lot of different organizations, the University of Nairobi, Kenyatta, several university hospitals in Switzerland, in several countries across the world, Yale and others. And it's incentivized. And as you saw there, it's very important that if you challenge the model with tough questions and rank their answers and correct them, then you can obtain these kind of points. We're not doing this to infantilize it and to go, oh, you earning points, good for you. It's about understanding that you can't just ask a question once and nudge the model once and expect a good response in making a new model. We have to have the quantification of how much you need to contribute in order to turn your model into a model that's reasonable for your setting. It's easy. This last 2 minutes, you can ask any question you like as well, and we can enter a question here. I'm not sure, but let's say if anyone has a question, please put it on the in the chat. I don't know if there's anything in the chat, but please put any questions you'd like to ask our model in the chat, any challenging questions about the Philippine context, but we can imagine something like, let's go, oh, sorry, Liva, just here. I have a patient with hypertension, in her third month of pregnancy in the Philippines. Oops, spelled it wrong. Yeah, in the Philippines, where now should I treat her? Okay, so let's hope that it gives some good responses. And what we're doing here is, so I'm sending the question out, and you can see that it answers very quickly. And there are 2 answers, right? And here in the hospital that I'm at now, they are not in the in the anonymized stage. So you can still see that this is Meditron that's answering the questions. And you can see that it's giving 2 answers, right? Which is critical because we need to have a preference between 2 answers in order for the model to update to ensure that it knows what it should go toward and what it should be nudged away from. And you can see here that hypertension in pregnancy has many different causes. It can be chronic hypertension, gestational hypertension, and now it's giving some like various treatment guidelines. It's giving lifestyle modifications, and I'm seeing that it says quite a few things about chronic hypertension, and that's interesting, but it didn't say anything about preeclampsia. So we've got Meditron answering twice, and in the second one, I was trying to get it to see if it was answering something about preeclampsia. I also want to see if it's got something to do with the Philippine context. And I hope that you are thinking about some questions we can ask Meditron. And I'm looking over here. Um, and yes, so what is the recommended strategy for screening gestational diabetes? I saw there, that's a great question. I'll add it in, and you can also have a look at that later. So I'll copy paste that and put it in just afterward. And you can see that it's got likely diagnosis, and they give some very reasonable ones. As a doctor, I much prefer this one. This one was it missed out on a lot of options. This one is much more structured. It's got treatment recommendations for each of these. I like this one. I'm going to prefer it and vote for it, right? It was a no-brainer. I didn't look for everything, but it's got all of the keywords that I like, and let's pretend that I did it more carefully. And then I can say, well, this one was just incomplete, and it was contextually inappropriate. It didn't give me anything specific about the Philippines, and that was not good enough. And this one, well, it aligned with guidelines. It clearly understood the question. It had pretty logical reasoning. And let's say that it was complete, but not complete enough because maybe it missed something. Let's pretend. And that thing that it missed, well, it was not harmless, but it wasn't. It was whatever. We guessing. But otherwise it was fair, and it wasn't contextually aware, maybe because it didn't do anything about the Philippines, because it didn't know about our guidelines, maybe. But otherwise, I was confident, and the model was confident, and the communication and tone was good, and it was clear. So now I've evaluated it. It took me usually an average of about 5 minutes, and now I can submit it. I'm not going to submit it because this is a live hospital that's doing their own. And I can go and see how many I have submitted once I have done it. And I can see how close I am to authorship of the paper, getting authorship on the paper, and how close my university is to getting a model back from all of their contributions. Now, this university, I have contributed none, right? So that's correct. And it's busy calculating all of the contributions that have been made, because this hospital went crazy, and they did 6,000 contributions when they only needed to do 900 across all their different settings. So very impressive feat that they were able to do. So I was very happy with that. And just, I'm not going to wait for that, but I'll just come here to the review tab. So we can also go and see other contributions here. They have just ended their contributions. So maybe we can't see all of their contributions at the moment because they've just finished they've just submitted their final contributions. So then you can actually go and see all of your folks, your fellow kind of colleagues and what they've submitted, and you can go look at them as well. And then just here, because I just want to be quick, we can also upload our own guidelines. So here you can upload your guidelines, and then we can do some retrieval augmented generation, because it won't know the Philippine context guidelines if they haven't been uploaded. And so we can then upload them, and then later on, remember that it doesn't get updated live, we can then go and test it. So these are all the different things that we can do. I don't want to spend too much time because I first want to go back to that while you ask questions and I open it up. I'm just going to put in this question that was asked in the chat, and then we can see the answer. So with that, I'm going to leave the answer on the screen, but I invite you to ask any questions. And I hope that the presentation was clear, and that if you are interested in joining and signing up, to please reach out, and then we can simply make a Philippine context setting for this over here. We can just make a Philippine context sign up page, and then you could imagine to just sign up and have the yeah, sign up and start your own move. So I hope that was clear, and that people can. Oh, I stopped sharing my screen. Sorry, just let me put that back.
Well, thank you, Dr. Hartley. Wow, that's more than I expected tonight. So, three questions here in the chat box. Actually invited Dr. La Peña to co-host with me, but he has to pay attention to the first year anniversary of the death of our chancellorship, Dr. Manny Agolto is the editor of the Philippine Journal of Otolaryngology. So I'll try my best to field these questions. There's a question here from Dr. Iris Tan. Before I post a question, was any of the data come from the Philippines to train Meditron at all?
So yes, some of it, but not all. And there's so many more guidelines from the Philippines that could be used. And so what we are using are the WHO guidelines that are available, and that's, to my knowledge, the only information that we have from the Philippines are from WHO. So and you can see I'd be very interested. This is the result that just came out of the question that was asked, that was asked in the chat about, according to the Philippine guidelines, is this your strategy? So here it says the Philippine adopted the recommendations from the WHO. So this answers that question in some way. And the International Association for Diabetes and Pregnancy. So did it understand? Has Meditron understood where the Philippines is getting their guidelines for this question, which is for diabetes? I'd be very interested to know if this aligns with the strategy, and the person who asked this question can maybe tell us more. But this would be very interesting to see if in any one of these are aligning. But we do have representation, but maybe it's not enough.
Iris, you're on. You know, this is a
Yes, I
this is
asked
a
that
live
question.
interaction. Walang pandit. I'm sorry for speaking in Tagalog.
Yes, I
But
asked that
here is
question, and
our country expert in medical informatics. So, can you elaborate on the question? And I know you're going to move this effort forward from the Philippines.
okay, so
Iris, yeah, help.
I'm not only in informatics, but I'm also an endocrinologist.
Yes.
And I was one of the people who actually wrote the guideline for diabetes, specifically on gestational diabetes. And Meditron has it correct that we did adopt the IADPSG. And so the things that are on the second panel are actually correct, that we are doing a one-step screening, because the old practice used to be a two-step. I like the interface, Dr. Hartley, on how we can evaluate the responses. I think that's very good that we only have two options, but then when you choose something, you actually have to evaluate more of it. I understand that people will be very interested. Like you said, this university was only supposed to submit 900, they'll submit 6,000. I foresee the same happening here. Based on my previous experiences running AI workshops for medical educators. Since I'm already talking, I just have one. Can I have one question already, Dr. Cabellion?
Okay.
Dr. Hartley, how much prompt engineering expertise do you expect from the people who actually ask questions of Meditron?
Very, very little. I think that we want to ask the questions. We have some guidelines, and we have an onboarding session. So usually what happens is we say, please, if you are interested, so all you have to do is you show your interest. We have an onboarding session where we guide some principles in the way that you should prompt Meditron, and it's not even Meditron, it's several models that we want that you're prompting, and we just go, make sure that you tell it where you are from. So say in the Philippines, like the question you asked was perfect. It was natural. You had no experience before in this, I didn't tell you, we haven't met before. And you said, in the Philippines, what is this? You are testing whether it knows something about the Philippines. That's one type of question. Another type of question might be that it's biased. Is it following your ethical standards of how women should be treated for XYZ? Or do you know that there's a certain bias about how people are maybe not wanting, something controversial that's in your setting? Like in India, there's a controversy about knowing the sex of the baby before birth. Is that relevant in your setting? So all of these kinds of controversies, you want to kind of see how Meditron handles it, or how any model handles it, so that you can nudge it towards the culturally appropriate response.
Okay, so thank you, because my workshops now are actually about teaching prompt engineering to medical educators to help them with teaching their classes. But this one is more clinical and definitely more exciting. Thank you.
Thank
I
you.
see. Oh, there's a question here. A note from Dr. Rodolfo Rafael. Sir, can you show yourself? And are you on? There you go.
Okay,
Dr.
so
Rafael,
the question there was
you
how
will
to.
be
I think
able
it was
to help
already
us, because I have a few residents, not only from the Philippine General Hospital, but also from master's degrees from Diliman, who are very interested in in getting this projects going. It's going to be a lot, but we would welcome very much your input and even what you have to help us with this effort. Can you tell us where you are?
Yes, sir. I am from Pangasinan. I am here from Pangasinan.
Pangasinan.
Yeah,
Okay.
actually, I am interested to contribute also to use and to evaluate this model, this platform, and hopefully I can be part of it so that we can also use it. And by the way, I am also teaching in the medical informatics here at Lyceum College of Medicine.
Huh?
So probably I can also share this with my students that there is such thing as this Meditron platform. Yes, sir.
I see.
Well,
Great.
that's wonderful. And to answer your question, then, by the way, I saw another question that someone wanted to ask to
Yeah.
Meditron, so I've just put it up in the background for your interest, and I hope it got it right. I'm not sure, but we'll see. And the question that you had was how do we show our interest? We just need to, usually I have a sign up form just here, but I saw that my QR code didn't show actually in the end on my last slide. I don't know why it wasn't there. It just doesn't want to come out. So then what we can do is we can just maybe have a point of contact where we can collect the information of the people who are interested. We make a group for those people, and they sign up, and they can start with an onboarding course. So that's it. That's how easy it is, and very, very welcome to bring. The more experts we can bring in, the better. And yeah, so very excited to start this off with you guys as well. Yeah, and remember, so the SHUV, this university hospital that I have here, every single service, that's because they were organized. There needs to be a little bit of a cheerleader, I would say. I think that the hospitals that we saw the best response from was where there was someone who was centrally coordinating the effort between everyone. So they had these great emails where they said they had like these competitions where they're like, oh, this service is better than that service, and it got quite heated. And people really enjoyed it. So I think that that was really helpful to have a central coordination of the initiative as well.
Wow, that was
Dr.
a
Pavilion, can
question.
I ask a question? Can I ask a question?
Okay, go ahead. I
Okay.
was going to comment. That was
Yeah.
a question.
Given,
Hold on, Dr. Rafael.
yes, sir.
Okay,
Given the medical AI tools like Meditron aims to provide region-specific guidance, how does the platform address discrepancies between international clinical guidelines and local practices, such as those in the Philippines, where resource limitations, cultural norms, and access to healthcare differ significantly?
Well, you've asked the question that the move is trying to answer, right? And the move platform is really trying to say, well, there are international guidelines, and we do want to aspire to them. We don't want to forget the international guidelines. It's okay if the model says, go do an MRI for a headache. Okay, if that is now the standard in like, a higher resource setting. But we wanted to make sure that it understands that may not be available and that it gives reasonable alternatives for our setting. And that's what the move is supposed to be doing. We're supposed to nudge it in that direction. It should know that there's some things to do, but that it should know that we're and exactly I just saw here that Iris has said that there's a Philippine Department of Health repository for approved clinical practice guidelines. We don't have access to that. This is exactly what I kind of just flicked through some of the pages, and one of the pages of the move that I clicked through was where you could upload your clinical guidelines, and you can just dump them there, and then we can, for the next iteration, because of course we first want to test what Meditron is on its own, so we kind of freeze it so it doesn't, and then when you update it later then we can use the clinical guidelines that you share with us and your feedback so that it nudges. It doesn't nudge live, right? So if you ask a question and correct it, oh, I didn't show you that, I should have showed you that, I'm so sorry that I forgot, but just quickly show you that it's once you've selected, maybe you prefer this one, you can also edit it to make sure that, like, you can say, well, I don't like XYZ part of this, and this should be deleted or whatever. And then when you can see that it's edited, and we can also then correct the answer when even if we find it better, that we think that it should be corrected there, or we can edit it further and add certain things to it, so that you can kind of see that's affecting the model as well. Yeah.
Thank you, Paul. Thank you.
Oh, fantastic! I already got a link to the guidelines. Very, very helpful.
Here's Dr. Lance Oliver here. Maybe you could show yourself. He says that there's a large ethnobotanical record of medicinal plants in the Philippines. Could that data be embedded into Meditron? And
well,
then
it depends.
we don't have to know, we don't have to go and find out whether my ampalaya, that is the bitter melon, I think they have that in Africa, will be able to cure my gout. So would you make a comment on that with your experience from Africa?
So yes, well, it depends on what the experts in your country want to be represented in this model. If you want, pseudo medicine practices to be represented, I suppose you could do it. But if this is an ethnobiological a repository of medicinal plants that actually have cultural relevance and are respected in terms of evidence-based medicine, and you want to be able to represent those, then that is something that can be represented in Africa. Traditional medicine is very important, but there's some things that are very dangerous and other things that are not, and it's not regulated. And so it's more about what we're interested to know is, like, what are the local plants that could cause liver failure, and how to treat those poisonings that happen when traditional medicine goes wrong, and what are the interactions with our HIV medications and others. So we often have treatments. People get treated by traditional healers actually with crushed up paracetamol, with crushed up tuberculosis medications. And so we need to also know how to respond to those. Yeah.
I see. Dr. Gisela Concepcion, right there she is, I think, going down the stairs. Dr. Concepcion just led the first artificial intelligence conference in the Philippines in collaboration with Dr. Naval. Our distinguished scientist from the Philippines, asked this question, and I noticed that there are some health workers that are working in the rural areas there. We have the same thing in the Philippines. We call them barangay workers. Would they be able to have, will we be able to train these barangay, we call them barrio, or the small municipalities, to have them on their smartphones on how they could treat these patients. And Dr. Concepcion, if you want to elaborate on your question, but ma'am, you're always free to intervene or to add.
I think she was busy. She was going downstairs, and she might have just lost because her video got frozen. So if in case in case you can't answer, I would be very interested to understand how the health workers how those barangay health workers work, because we rely on them so heavily in South Africa, right, and in Africa in general. And what we would want as an end goal, not in the beginning, because that's not appropriate, but as an end goal, to have that right information at the right time in the right place, so that when you have validated a model, you could imagine that that model could be in the pocket of these barangay who are in the community and now can ask their question, and hopefully ask their question in the language that suits them. We're still a bit far away from that, but this is a very important step into that direction to make sure that, at least in English and eventually in local languages, that these models can be used in a context-specific way.
Dr. Angeline Lau is a board director of PAASE. Asked the question, could we also explore the possibility of comparing clinical practices across various countries to help improve a country's guidelines? Maybe the Philippines can improve the guidelines of the other countries, or vice versa. Have you seen differences in guidelines, and is there or is it specific to a country and you really can't use the guidelines of one country to the other, or can it be universal?
I think it's a really important question. I don't think that we should exaggerate the local nuances either. I think that there's so much that is similar between countries and in the world. There's certain medical standards that we should just always keep, right? So I do think that there's a lot more that is similar than that is different, but the things that are different are important. So and the thing is, you don't want to learn maybe from Burkina Faso because it's just a different epidemiology, but you may want to learn from countries that are surrounding yours because there's more in common. So I just think that there are ways that if the Philippines make their own model, it'll be useful to surrounding countries as well. And I'm quite sure that a Thai model would be useful to Philippines as well. So that kind of like regional model would be really, really helpful. So yeah, I would definitely suggest that too. Yeah.
Al, you have your hands raised, sir.
Yeah, thank you. First, I'd like to thank Annie for taking the time to actually instruct us here in the Philippines. We indeed just had our AI conference organized by Frost and Giselle Concepcion for UP. I'm a consultant for UP for technology transfer for the last 10 years. I was based in the US for biomedical development. So what I'm trying to do is organize indeed an AI applications for some of the disease killers in the Philippines, namely breast cancer, diabetes, cardiovascular diseases. And I can really see also, because I am part of a health worker workforce development. And indeed, the grassroots, like the one you showed in Africa, is the equivalent of our barangay healthcare workers here in the Philippines, which is very active during COVID for being able to isolate and do contact tracing. And we wanted to capacitate them, indeed, based on your demonstration. I can already see some of our, especially our remote areas, especially if they can access the information locally, will be very beneficial. But of course, my first question is more of applying your modular applications where you use images to validate specific diagnostic capabilities like thermolytic profiles, matching it for recommendations for breast cancer mammography, which has been done actually in India in the thousands, and we've been wanting to look at that possibility of doing it here. And I've discussed it with Pros earlier, except that I have not found an actually easily adaptable model. Maybe Meditron would be the model for doing just that and accelerating the development. I don't know, maybe Pros can comment also with what we've seen today. Is there something now that can be implementable if we have data coming out of PGH and matching it with some of the available data on thermolytic profiles that's been taken by some of the earlier hospitals that are adopting it. Can we match them and then eventually detect recommended mammography candidates? Because our compliance here is very low. I think we're down to about 20% compliance, and there are thousands of patients dying in breast cancer without seeing a doctor or not even having a mammography. So that's just a use case that I wanted to see if your model can indeed accelerate our development here in the Philippines. But again, thank you for definitely presenting to us. And again, thanks, Billy, for being able to invite on to PAASE. And I'm looking forward to potentially several activities on Meditron now. I think Dr. Iris is here, Ross is here, and definitely our doctors both in UP Manila will hopefully grab onto this opportunity to be able to indeed take your, for lack of a better word, car for a test drive.
Well,
Thank you.
Here's thank you, sir. Here's a question or somebody's trying to say, I am Dr. Aguda. I am a Filipino PhD biochemical engineer working for a global healthcare company. How can this AI platform be useful for medical device companies in gathering gathering information and help them make these wearables more successful? I think is the point of the question.
All right, and I'm so sorry. I have I'm in the middle of Africa. I have some African internet, so I just dropped off and I came back out. So I'm sorry if I missed something, but I did just drop a link in the chat. Because in the background I was just because my link didn't work on my slide deck, so I don't know why. So now I've made the link now. So please, if you're interested to join the move, I've dropped it in the chat there, and you're welcome to then sign up on the interest form. I had to just quickly make it in the background, but I think it looks good. And to answer your question, first of all, I just want to comment. I'm almost a little bit embarrassed because I'm so used to speaking with groups of doctors who don't know anything about AI, because that's the majority, right? And I just feel like everyone here who's been asking a question has got like a very strong background in AI, and so I should have asked. I should have known my audience before I started. So sorry if I was telling you things that you already knew. Yes, but on the other side, I would definitely say that mammography is such an important use case, and we really do want to make sure that we can have those use cases available, either to train the model further. If you have data available, we can train it and continue training the model to make sure that it understands mammography standards in your setting. So that's also something that we'd be interested in finding out if we can work on, and also to see if it just works. So you can either test or continue training. So it may be test to see how does it understand mammography? Is it good enough? Maybe it's terrible. And then to say, well, based on our expertise, this is not good enough. Therefore, we need to improve the model. Or based on expertise, it just needs a little bit of nudging. Yeah.
Okay. Oh, we can go all night on this, but I have a suspicion it's probably 1 a.m. where Dr. Hartley is. So
don't worry. Yeah.
we have many more questions here, but I don't think we will be able to answer them. But here is something in the future. Dr. Hartley will actually be in the Philippines in
Yes.
February.
Correct.
So everyone who is attending here we're going to hopefully host it at the Henry C. building at the College of Medicine. And I'm trying to arrange this, whatever you call it, a symposium or so, but you can personally be present there, and hopefully the others will be there. I'll be, of course, Dr. Nadal will be one of our resource, and as we go through with this. But that opportunity is coming in February. So we will have a personal opportunity to interact with Dr. Hartley, and they will also be trying to help us with a couple of our projects that we have started in the Philippines. But with this conversation this evening, there's really a lot more that can be done. We're just beginning. Dr. Rafael, nako, pupunta kami dyan sa Pangasinan. I just said that we're going to Pangasinan and visit what they're doing in Pangasinan and get them over there. So be ready, sir. I don't know how well
Yes, sir.
that will happen. Well, I'm sorry I have to, we can only have so many minutes in our time, but first, I want to thank everyone who has attended. Of course, you have to thank especially Dr. Hartley, who has presented this thing for us. It's just the beginning and of a conversation. We have more things to do. And Dr. President Gladys Concepcion, would you kindly complete? I'm sorry, I'm getting all confused. Make a presentation, ma'am.
Okay. I'm coming back on because
Ah.
Gladys may have left for an appointment that she had to go to
Ah.
UP Diliman. So I will present the certificate of appreciation to Dr. Ann Hartley, MD, PhD, MPH, for being our speaker at the Philippine American Academy of Science and Engineering, PAASE, webinar entitled Meditron, Medical Domain Large Multimodal Model, Potential Use in the Philippine Setting, held on January 10, 2025. So presented this day, January 10, 2025, with our greatest gratitude. Signed by Dr. Gladys Completo, our Cherise Completo, PAASE President, 2024-25, Philippine American Academy of Science and Engineering. So it's a simple certificate, but we really thank you for that wonderful information. It's really very useful to everybody. Thank you so much, Dr. Hartley.
Thank you so much. I really
Okay.
appreciate all of your time. It's an honor, and I really hope that we can work together soon. Excited. Meditron, the whole Meditron team is excited about the opportunities in the Philippines. So thank you.
Yeah. Great.
Thank you.
Well, as Shakespeare says, all things have come to an end. We've come to the end. We've come to a pause, because I think this is not, like I said last week, this is just the beginning of I think many conversations. Again, thank you everyone for attending. Thank you, Dr. Hartley, for the tremendous presentation.
Yeah.
So
Thank you.
I will say goodbye now. Oh, Marge?
Yes. So
Ma'am?
before we leave, we would like to let you know that we have another webinar coming up on Friday, January 17th. And this will be presented by Fernando Garcia, PhD. And it will be, again, a health-related webinar on good health and well-being, insights and challenges in the Philippine context. Maybe we can invite Dr. Hartley to join this as well.
It sounds like a good context for Meditron.
Right. Yes, it's very fitting to what you had talked about today. Yes, and maybe we can exchange some insights at that presentation. So we invite you to join that. Please register on that site, and we'll see you at that time. Okay.
Bye, everyone.
Great.
Okay.
Thank you so much.
Thank
yeah.
you.
Thank
Thank
you.
you,
I think
Madam Vice President. Always very, energetic. Thank you. So
thank you. Thank you,
we're,
everybody, for coming. Yes.
Dr. Pebes Claros, thank you for hosting this. And we will see you again next time.
Yes.
All right? Okay.
Good night, everybody, or good morning.
Good night.
Bye. Good
Good
night,
night.
everyone.